Hi, come with me to the Cabrillo Marine Aquarium with me and my group members. Before we get into the actual fun part of this video, I want to talk about the purpose of this video. So today me and my group members are making this video to teach whoever is watching more about the different geological features Cabrillo Aquarium and the beach has to offer. Alright, so let's get into it. So I think it's important to mention where Cabrillo Marine Aquarium is actually located, because while we were making our trip there, one of our group members actually ended up in the wrong aquarium. They ended up in the Aquarium of the Pacific, which is another aquarium that is near Cabrillo Beach, but it's not the Cabrillo Aquarium. So please be aware that there are two aquariums around the area. Inside the actual aquarium, there wasn't much related to geology, but there was a small area that displayed different types of rocks and minerals such as sandstone, limestone, obsidian, and sulfur, along with many more. The aquarium also has a couple whale fossil rocks that you can see and touch, but these whale fossil rocks not only can be found inside the aquarium, they can also be found outside the aquarium in the Monterey shell cliffs above the tide pool. Well, now that we're moving on to the outside of the beach, Mr. Derek over here is going to tell you more about that.
Believe it or not, every time you visit Cabrillo Beach, it's a little different each time. Hello everyone, my name is Derek and today I'll be talking about the coastal process at Cabrillo Beach, specifically focusing on how littoral transportation is changing the shoreline day by day. We are currently located in the intersection of Cabrillo Beach, and as you can see, the coastal process starts with longshore currents. These currents form when prevailing winds create waves that approach the shoreline at an angle. When these waves reach the beach, they create currents that move parallel to the shore within the surf zone. This happens because waves generally don't hit the shore straight on. Instead, they bend or refract as the water gets shallower near the coastline. Together, these mechanisms create littoral transportation, the overall system that moves sediment along the coastline. This process is constantly stripping off more sand than is naturally replaced in this beach. Let's now move to the outer section of Cabrillo Beach. If you didn't already know, both the outer and inner beaches at Cabrillo were artificially created in the late 1920s when sand was imported to make the area more appealing for tourism. However, the beach has a moderate slope and is exposed to the open ocean, causing waves to break closer to shore and making it more vulnerable to erosions. As the high-energy waves strip away this lighter sand, exposing the underlying pebbles, cobbles, and boulders that were originally buried beneath. Over long periods of time, erosions can become a significant problem. It is the exact reason this beach requires sand replenishment approximately every 7 years. In conclusion, Cabrillo Beach is a perfect example of the ongoing cycle of erosions and replenishments.
Now, thanks to this erosion that my group member talked about earlier, we can now see the outcome that these strong waves bring, which are the tide pools. So, how are tide pools formed? Essentially, tide pools form in coastal rock formations, often in igneous, sedimentary, or metamorphic rocks. As you can see here, this is where we can find most of the tide pools at Cabrillo Beach. Since we are on the outer beach, it is much more rockier than the inner beach, so it makes it a bit more difficult to walk through. Speaking of which, harder rocks like basalt, granite are most resistant to erosion, which creates stable tide pools. Softer rocks like sandstone and limestone typically contain natural weaknesses like cracks, joints, or bedding planes, which make them more prone to weathering and erosion. Overall, these features make the initial depressions where tide pools can later develop. Here in Cabrillo Beach, the tide pools here are part of the rocky intertidal zone, shaped by millions of years of geological and oceanic processes. The area is part of the Monterey Formation, specifically the Altamira Shale upper member, which features sedimentary rock formations that primarily consist of sandstone, shale, limestone, and siltstone. These rocks are soft and have been eroded by waves, tides, and weathering. The erosion patterns in the tide pools are shaped by a combination of chemical weathering, mechanical weathering, and a bit of biological weathering. Wave action is a primary example of mechanical weathering here, since the constant pounding of the waves along the rocks break apart the formations. These rocks are a good example of that. As tides rise and fall consistently over a long period of time, the rocks form a wave terrace. Water fills the cracks and the crevices between the beds, forming the tide pools. Not only do powerful waves cause the rocks to weather, the salt water itself also plays a significant role when it comes to chemical weathering. In this case, solution weathering is a type of chemical weathering that makes limestone dissolve when it makes contact with the seawater. Over time, this causes the rocks to form lots of pockets and depressions, which then become tide pools, as you can see here. Now, when you visit these tide pools, you can see that they are filled with marine life. But did you know that some of these organisms also contribute to weathering? For example, burrowing organisms like sea urchins and mollusks burrow into the rocks, which accelerates erosion. So those rocks with holes, yeah, it's probably the work of one of those fellas. Not only that, certain types of algae and microorganisms can produce acids that break down the rock surfaces. Some coastal plants growing in cracks also contribute to rock fragmentation as well. Overall, these weathering processes continuously reshape the tide pools, making Cabrillo Beach a dynamic and evolving coastal environment.
The sedimentary layers at Cabrillo Beach are like pages in Earth's storybook, recording millions of years of geological history, each layer representing a unique period with materials like sand, silt, and mud settling in a marine environment. Over time, these settlements hard into rock through a process called lithification. Weathering and erosions is constantly happening due to the winds and waves. Over time, you can see the big changes it's had on the beaches. Due to all this, they've had to build barriers to protect from worsening and causing more destruction onto the homes and buildings on the cliffs and around. Deposition occurs with the constant waves and winds activity. With this, the rocks will begin to break down and dissolve. Sand, silt, and clay have been carried into the deep ocean floor by the waves, and on the sea floor, these materials form layers with coarser fragments such as sand settling in the shallow or more turbulent zones, with smaller fragments like clay settling into deep and calmer places. Compaction and cementation comes from the weight crushing the bottom layers, and as more layers gather on top over time, you can see all the many layers as shown here. These particles were cemented together by seawater containing minerals like silica and calcite, creating sedimentary rocks such as sandstone, shell, conglomerate, and breccia.
Now that we know that the Monterey shell cliffs were formed underwater, we have to answer the question of what caused them to be uplifted.
Tectonic activity and the Palos Verdes Fault is the two factors that caused the Monterey formations to be uplifted and exposed above sea level 3 million years ago.
Obviously, over time, these cliffs will start to erode, but my friend Jocelyn will be talking about the ways we can prevent and slow down erosion of the cliffs.
These cliffs at Cabrillo are made of sandstone, a rock that's been forming over millions of years. From far away they might look strong and solid, but sandstone is actually pretty soft and breaks down easily over time. If you look closely, you'll notice cracks, loose rock, and crumbling edges. That's all from weathering, which happens when wind, rain, and ocean waves slowly wear away the rock bit by bit. Over time, that can lead to big pieces falling off. The question is, why don't the cliffs completely fall apart? That is where people step in. To keep them stable, engineers use special tools and techniques. They build walls, install drains to move water away, and even drill bolts into the rock to hold everything together. In some places, they also use wire mesh or netting to catch falling rocks and protect the trails below. All these efforts help slow down erosion and keep both the cliffs and visitors safe, especially during heavy rain or earthquakes when the ground gets shaky and loose rock becomes a hazard. But not all cliffs are reinforced. This one, for example, shows no sign of human-made erosion control. There's no mesh, there's no bolts, there's nothing holding it up. What might look like wire is actually just dried up seaweed stuck to the rock. Here you can really see how nature shifts the cliff on its own. The layers are breaking down and small caves are forming at the very bottom. This is a very clear example of how sandstone changes over time when it is left alone.